So lecture number 22, Introduction to Shaders. Here are really two great resources called the Book of Shaders and Shader Toy, both of which we will be visiting today, and can really help if you sort of want to start your journey into shaders. And if you're doing anything graphics related, whether it's game design or not, shaders are going to be the way that you do things from now on. Shaders are absolutely wonderful. And so as a cool little introduction here, let me turn on my desktop sound. Here is a video from the Mythbusters explaining the difference between a CPU and a GPU, and it's sort of a nice introduction to why we would want to use shaders in the first place. So let's see what's going on here. So that was it's a pretty funny demonstration, but it's literally what's happening, right? If you use the CPU to draw everything, then you're doing like one little pixel at a time, or maybe if you're using some SIMD, maybe you're doing a few pixels at a time. Versus shaders can be used to do multiple things at a time. So let's have a look. Shaders are essentially programs that you're writing that do something graphical, that are run on the GPU, and they run in parallel. So you can write a shader essentially that's running for every pixel of your display. So shaders are programmed as a series of instructions in GLSL, and that's GL shader language. GLSL ends up looking a lot like C. So if you're familiar with C or C++, which this course is in C++, you should be able to read and write GLSL no problem. There's a few differences, but it's not that big. Shader programs are compiled by the GPU. So the way that you write a shader program is you define it in a text file. That text gets sent to your GPU, and it's compiled on the GPU where it's then run. Shaders are executed in parallel on the GPU. And there's two main types of shaders, vertex shaders and fragment shaders. Now, there's a whole pipeline of stuff that goes on with shaders that we don't need to necessarily know about, okay? So if you want to get deeper into things, there's this, like I said, there's this whole pipeline different from vertex shaders and fragment shaders and how this interacts with your program, but we really are not going to be dealing with this sort of low-level stuff, nor do we need to for the context of this course. Also, as far as vertex shaders go, vertex shaders are going to be executed once for every vertex in the thing that you're drawing, okay? They're not commonly used for 2D shaders. They have less impressive effects for 2D stuff, and so we're really not going to be talking about vertex shaders. And I know that I'm kind of completely skipping over vertex shaders, but they're not really the interesting thing for us in this course. We want to be dealing with fragment shaders in this course. So fragment shaders are executed once per pixel, or frag, being drawn. They're executed in parallel by the GPU, and every pixel of the screen is being calculated in parallel at the same time. And so given an input pixel position and color, essentially the fragment shader is going to be outputting the color that you want to replace it. And so the inputs are going to be this fragment coordinate, so the pixel coordinate, and the output is going to be the color that you want that pixel to be displayed on the screen. Now, there can be more complex fragment shaders with more complex inputs and outputs, but we're essentially dealing in this course with the basic type of fragment shader. And again, the whole point here is that the CPU would be outputting like one of these paintballs at a time, right? Drawing the whole screen sequentially, versus if we can write a shader program and then send it to the GPU, then all of these inputs will be processed into all of these outputs at the same time, and we get a much, much faster graphical running program. So here, there's a good YouTube video right here, which you can watch. It's an overview of the GLSL language. But basically, all you need to know is that a lot of it is very similar to the C programming language, and the way that we're going to be interacting with things is we're going to be dealing with vectors. And so a vec4 for example, can represent an RGBA color. So red, green, blue, and alpha. So if we say vec4 RGBA or vec4 color equals something, so RGBA, just like we could in C, then that is defining a vector with 4 elements. Similarly, vec3 color could just be the RGB. A position could be an X and a Y. We can also define a vec3. So I'm going to be using this shortcut way of defining things in my examples. So when I say vec3 gray 0.5, what that does is it allocates a new vec3 and every element gets the value 0.5. So even though it's a vector with 3 elements, if we just pass in one argument, it sets all the elements equal to that thing. Similarly, I could say vec4 RGBA, and instead of passing in all 4 things, I could pass in color, which is a vec3, and then alpha, which would be just a floating point value. So the 3 here plus the 1 here would be the 4 for the RGBA. So basically, what we're going to do is we're going to have a look at the book of shaders. I'm going to open that website and go through like the Hello World example. And then I'm going to open up Shader Toy, which is a website that lets us edit and program, edit, and run shaders in real time within a browser, which is pretty ideal. And then I'm going to show you how you can, once you've created a shader or you've downloaded a shader from somewhere, how you can actually use it in your game or in your project. Okay, so we'll do that, and then I'll play a quick video of some of the effects that you can get with shaders if you so desire. All right, so let's go back to the browser here, and I want to quickly show the website, which is the Book of Shaders. So this is sort of the, if you go to the Book of Shaders, it's going to give you this nice table of contents so you can go through. There's nice exposition. It really goes through from the ground up, like what is a shader, and like what can you do with them, the mathematics behind them, and stuff like that. So I've just opened up like the Hello World example of shaders, and just to show you what this website is, first of all. So for example, this website is really cool because you go down, you're reading, and here's an example right in the browser. And then you read, you go to the next one, and then as you're reading, oh look, here's another example right in the browser. You can edit it in real time. And here's another example right in the browser that you can edit in real time. So let's look at the very first one. So right here, basically, is the entire shader, okay? And so inside a shader, usually what's going to happen is instead of returning a value, what we're going to do is there's going to be some output parameter. In this case, it's fraggl underscore frag color. And whatever you set this value to is going to be applied to this whole canvas right here. Okay, now this is the most basic possible shader where you're just outputting a single color. So over here, I've got a vec4 with an RGBA. So this is the red, green, blue, and alpha. And as you can see right now, it's outputting 1 for the red, 0 for the green, 1 for the blue, and 1 for the alpha. So if you combine red and blue, you get this purple color. So if I change this over here to 0, what you get is red. So this is literally the program, right? This is a shader which runs for every pixel over here in this display. And this website is really neat because it has this canvas here that uses WebGL, and the shader runs on that canvas. So in real time, we can update these things. So if I have red and green, that's going to be yellow. Red, green, and blue is going to be white. If I take away the red and I just have green and blue, then that's going to be teal. Okay, so it's all about just setting this variable to the color that you want to be output. But of course, there's much more complex things that we can do, right? So let's go on to the next page, to the next example. Some other things that can happen is that you can take in these variables. So variables that are passed in to your program are called uniforms, all right? So an example of this might be the time, so maybe the current time in milliseconds or something like that. You might have the mouse pixel coordinates that are passed in, or you might have the resolution of the current viewport, right? So this might be like 300 pixels by 300 pixels. But let's just look at an example of this, and that is the time the time uniform. So if we want some dynamic effects in our shader, what we can do is use the current time to do that. So right here, what we're doing is, this example is passing in, as the red parameter, it's passing in the sign of the time variable. So let's open up our little blackboard here and see what's actually happening. So let's make this like a bit wider. Oops, that's not what I wanted to do. Resize. All right, so what's happening here? Well, we're going to want to be outputting the red pixel. So if we remember what a sine graph is, so if we have this value, oh geez, I don't want that to be red. So here's a little graph. So this is an XY like standard coordinate plane. And if you remember, sine looks something like this. So sine is Y, so sine of 0 is going to be 0. So sine goes like this. Right? So if this is our time variable, so this is time, and this space, the output of this, is our redness, our red variable, then over time what we should see is that as the sine value goes up, it's going to peak at 1.0. What a coincidence. My color space is defined between 0 and 1, so that's really good. But oh wait, I've got these peaks down at here at -1. That's no good. So what I actually want to do is take the absolute value of sine, and then what I get is something like this. Okay, so let me erase the sine. And what I get if I take the absolute value is a graph like this. So my red value is going to increase, then decrease, increase, then decrease, increase, then decrease. So what we see over here is exactly that happening. So I've got the absolute value of the sine of the time, and that is what my red value is getting. Okay? So let's just say that I want to have 1 as my blue value. So what's happening here is that the blue value is a constant value of 1, but I'm adding red based on this sine wave. So what's happening is, when the sine wave is at 0, I get no red plus blue. When the sine wave is at 1, I get 1 red plus blue. So I alternate between 0 red and blue, which is just blue, and it smoothly transitions into purple because that's the adding of the red. Okay, so that's what this is doing. It's just using the sine for that. Now, I can get some cool effects here. If I, for example, let's say that I want to take the absolute value of cosine of time for the green, then we'll see this alternating between a bunch of different colors, right? And that is because I can vary these colors in any way, shape, or form that I want. All right, so that's the example where we have all of the pixels being the same color, all right? So let's go down here now to what if we don't want all the pixels the same color, which is usually most of the time, right? So pretty much all of the time, we don't want the pixel, all the pixels to have the same color. So what we have here is an example of some uniforms that we're now using. So what we're going to do is we're going to use the resolution uniform. So the resolution is literally just the size of this canvas here, right? So we have this new thing that we're using called GL coordinate. And this is the coordinate of the pixel within this system. So let's just have a look. Let's make a diagram of this. And we'll do this by creating a snapshot here already. And now I can post this. All right. So here's what we have. So let's just say that the resolution in the X direction, this is going to be XY. So this looks like, I don't know, maybe it's like 500 by 500. Something like that, 500 pixels by 500 pixels. So that's what this resolution uniform is. It's how big in the X and the Y direction the canvas that you're drawing to, or the texture that you're drawing to, actually is. That's what the resolution is. This frag coord, so this fragment coordinate, is telling you where in the image are you actually editing right now. So here's where shaders start to become a little bit unintuitive. So remember, for each pixel here, 500 times 500 pixels, there's a shader program running on that pixel of the output. So literally, this is massively parallelized, right? But if you look over here, how do I know which pixel that I'm actually working on? So this is where the fragment coordinate comes in. So if I go over here, let's say I happen to be working on this little pixel right here, right? So if this is 500 by 500, then this coordinate is probably going to be somewhere around 225 by 80, something like that, okay? So this is the X coordinate, 225, and the Y coordinate, 80. So the X coordinate and the Y coordinate. So whenever this fragment is running, that is what this variable is. If you have glfragcoord.xy, this gets the two-dimensional coordinate of the current pixel that this shader is being run on. So let's see what this is actually computing now. What this is actually computing, this st, I actually don't like the variable xt. Let's call it xy. And this is going to now be xy, and this is going to be xy. Okay. And what we're going to do is we're going to start, let's just put this back so that we have red everywhere. So what is this line of code here doing? It's saying, let's create a variable called xy. And that variable's value is going to be the xy coordinate of the fragment, so the actual pixel location, divided by the resolution. Okay, what does that mean? Well, let's go back to our example over here. So if we have 225/80, let's bring up the calculator, right? So 225 divided by 500, that's going to be 0.45, okay? And then 80 divided by 500 is going to be 0.16. So in this new coordinate space, 0.45, 0.16. What we're essentially doing is we're forgetting all of the actual sizes of things, and we're getting sort of the ratio of where we are in the X and the Y direction. So this is sort of the ratio horizontally and the ratio vertically of where we're currently working inside the space, right? So this means that this pixel that I'm working on is 45% of the way over and 16% of the way down. All right? So if I go back over here, that is what this xy variable is. It's the ratio, or let's call it our xy, the ratio of the coordinate with respect to the size of this thing. All right. So let's say now that we wanted to do something like, let's color the shader more red as we go up in X space. Okay? So we want it to be black all the way over here at the left and red all the way over here at the right. So what we can do is we can just take the X component of this ratio of the pixel and use that as our red value. So remember, red being 1.0, just think about the math now in your head. How would I color it red over here and black over here? Well, if it's black over here, that's where X is 0. And if it's red over here, that's where X is 1. And that has like a natural translation. So if all I do is use this RXY's X value, then, well, when X is 0, the red component is going to be 0. When X is 1, the red component is going to be 1, and it smoothly transitions all the way in between. See how that worked? Now let's say that I wanted to have it red at the start going into black. Well, all I would need to do there is just subtract it from 1. Oops, I need to specify 1.0. So there, I have 1.0 over on the left and 0 over on the right. Okay, so where can we take this now? Let's add the same sort of scaling, but let's do it in the y direction. Okay, so let's take the ratio xy, the y coordinate. So now what's happening, if I set this back over here to 0, I'm going from 0. Oh, is this using the bottom? This is using the bottom as the 0 coordinate here. So if I take the y coordinate and scale it from 0 to 1 up at the top and color it blue, that's what I'm getting. So let's add back in the red. So now what this is doing is it's got red scaling from left to right and blue scaling from top to bottom. So in the bottom left, it's all black. In the top left, it's all blue. In the bottom right, it's all red. And in the top right, it's all pink. See how that works? And now what I could do if I really wanted to, I could do something like bring back in the sine value. So let's go absolute value of sine of u times that value. So now the red is fading in and out. See how that works? And it's being done in parallel, instantaneously. Well, not instantaneously, but it's being done on the GPU in parallel. So you're not taking up any CPU by this. All right. So this shader book will step you through all sorts of examples like this, but the user interface is a little bit limited. So what we're going to do now is we're going to close down the shader book, and I'm going to open up Shader Toy because it lets me do some more interesting things. Okay, so this is Shader Toy, where the syntax is just a little bit different, but it's going to be pretty much the same as we just did. So the variable names are a little bit different, but let's do the exact same thing that we just did, but we'll do it in Shader Toy instead of the book of shaders. So over here we have our shader, and we can see a bunch of different inputs that we get. So we get things like the resolution, the time. So instead of u_resolution, this is just calling it I resolution. And instead of u_time, this is calling it I time. Okay. So over here, we're going to set up that xy variable again, where we normalize the pixel coordinates from 0 to 1, right? Now, for the moment, the shader is all black because I'm not assigning any color to it. So over here, if I just said at the very end, frag color, this is my return variable, is equal to rg, or let's say vec4, and I'm going to combine. That's going to be 1001. Then that's going to be RGBA, so this should be all red. So it's the same thing, it's just a little bit different because it's in a new website, right? So let's comment that out. So let's see some different things that we can do now with shaders. And again, this is just the very, 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 very beginning. So ignore this for now. I've got this just copy and pasted here for later. But let's color the right-hand side of the image. So what this line says here is that if our x-coordinate is greater than 0.5, change the red of the output variable to 1. So if we run this, this is what we get. If we are more than halfway across the screen, then we get red. Similarly, we could say and xy.y is greater than 0.5. So this will say if we're in the right half of the screen and we're in, oh, that's supposed to be 0.5, the top half of the screen, right? Because it goes 0, 0 is in the bottom left in this coordinate system. Then I color that as such. All right. So that's how we can selectively color parts of them if we want to. Let's go back now to the example we had before, where we are going to increase red with the X value. So here we say our frag colors red so fragcolor.r, we're just going to set that equal to the x value of the coordinate. So as we go up in x, we go up in red as well. Then we can also increase the blue based on the y. So here we're back at that same place that we had it at in the book of shaders. Okay, but now let's do something a little bit more interesting, because in your games and stuff, you're going to have textures, right? So let's load in some texture values. How do I do that? Well, in your actual game, you'll load up a texture, you'll apply a shader to it, and you'll get access to those variables. And I'll show that at the end of the class. But within ShaderToy, what you can do is you can click down here, and you can load one of these sample textures that they have available to you, okay? So we click a texture. So here I've just got the London texture, and that gets loaded into the iChannel0 texture variable. So now up here in the code, I can say vec4 texture color is equal to texture. So I call the texture function, that loads the texture from iChannel0, and it gets it in the X and Y space. And then if I set my output fragment color equal to the texture color, then what we see is we output the texture, right? So we've loaded the texture, and then we've set the output equal to the texture. All right, so now we can do the same thing as we did before. So I can say, if we're in the top right half of the image, set the red value equal to 1. And that's what it's done. It set the red value of that equal to 1. But now it's also operating with that texture. So we're sort of modifying the texture that we passed in rather than just drawing stuff to the screen on a blank canvas. Okay? So let's see something else cool that we could do with this. So here's the texture. So let's create a grayscale image out of this texture. So if I have this color texture being input, what I can do is figure out the gray value at each pixel. And if I want to do that, well, one way of doing that is just to average the RGB color space, right? So I want to turn the red, green, and blue into some gray value. Well, all I have to do is add the red to the green and the blue and divide that all by 3. Okay? So now what I can do is I can set the fragment color equal to, well, I can do it this way. Gray, gray, oops, gray, gray, gray. Oh, geez, I keep typing periods. So gray, 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 1. If I do that, then I get the grayscale of the image, right? So what this means is that you can apply a bunch of different effects to your game, to textures in your game. So let's say we have Mega Man, right? And let's say in Mega Man, there's some ability of an enemy that like freezes Mega Man. And you want Mega Man to be like colored grayscale while he's frozen. Well, you might have thought before you knew what shaders were that you might have to go create like another set of animations or another set of textures where Mega Man is in grayscale and then check if this is happening, then load that grayscale texture. But no, using the shaders, you can do all sorts of cool things you want to the shader. So let's try some other image operations that we could do. For example, let's mask out part of the image. So what this says is, and now these grayscale values are between 0 and 1, where 0 is black and 1 is white, right? So let's say if the image, if the current pixel that we're processing is less than 0.6, meaning that it's pretty dull, if it's less than 0.6, let's output black instead. So if I run this, what you can see is in the dark parts of the image, it's black. Well, here, okay, let's change this less than to a greater than, and now you'll see all the bright parts of the image are black, right? Or I could just say, instead of doing this, I could take the inverse of the image. So I could do 1 minus gray, right? Oops, I gotta say 1 minus 0 because it thinks it's an integer. So now I've taken the inverse of the image, right? So there's all sorts of really cool stuff that you can do with this. Now, let me show you something even cooler. All right. So let's say that we have, I'm not sure how to upload my own texture to this. So I'll wait. I'll do another example later. But let's just say, for example, that we have this texture as we did in the beginning, and we want, let's say that this texture happens to be Mega Man. Okay, it's not, but let's just pretend that it is. When Mega Man takes damage, maybe we want Mega Man to flash red for a second, right? So what we could do, and now there's a bunch of different ways that you can do this, but I could just set fragColor.r equal 1.0. Okay, so that means that now I've set the red channel of the image equal to 0, which makes it much more red than it used to be. Okay, you could also do something like R channel red times equals 2, so it becomes a little bit more red. Oh, 2.0. So it becomes more red than it was, right? So let's just look, let's go back to the way we did that. And now, how would we make this flash red? Okay, well, what we can do is we could say, now let's use that multiply. So I like the multiply effect more. Let's make it 3 times as much. So now it's like, it's really red. So now we can say, okay, remember we had the absolute value of the sine of the time. And this is going to say absolute value of sine of time times 3.0. So this is going to be an oscillating thing between 0 and 1. And it's going to multiply the red channel by that. So what's going to happen? Ooh. But what this actually does is it takes away the red when this becomes 0. Right? So what we might want to do is say this is like 1 plus this. 1.0 plus that. There we go. So lots of different ways that I could do this. Now, one last thing is how could I, you can see here that it's flashing kind of slowly. How could I make that, that faster? Well, you could multiply the time variable. So multiplying the time variable, let's say over here where I had my sine wave like this, right? The x value, that's the time variable. And if I want this to be faster, well, I could multiply it by 2 and get twice as many cycles, right? Or maybe multiply it by 4. And so that's what I'd get in my image as well. So if I multiply this by 4, then the flashing, geez, I gotta keep forgetting to put in the point zeros. The flashing will be 4 times as fast. So let's say that you've got a whole scene that you want to draw. What you could actually do is instead of displaying it straight to the window, you could display it to a texture and then put a shader on that texture. So maybe if you got caught by an enemy, now your whole scene is flashing red, right? And so there's all sorts of really cool stuff that you can do with shaders. Let's keep going because I like playing with this thing. So let's stop giving you a seizure there. Let's load another thing. So it's on this website. It's really cool because I can load in these sample video clips that they have, right? So I'm going to have another texture color here. Let's put this down at the bottom. So this is Tech Color 2, and that's going to be from iChannel 1. So this is iChannel 1 down here. Now, down here, if I say fragColor equal Tech Color 2, then that's going to set the output pixel color to the output pixel color of this video. What's going on here? Frag color equals, oh, text color, sorry. Tech color 2. All right, so now we're just playing the video. Let's say we want to put Jean-Claude Van Damme here onto our Paris background. So what could we do to do that? There's a bunch of different ways that we could actually do that. But first, let's detect the green screen. Okay, now this is not a super high quality video, so the green screening that we're going to do is not going to be the best thing in the world. So let's go down here and let's make a color green. So vec4 green equals is going to be vec4 and 0.7501. So this should be 1 for like a really bright green, but before class I looked up the green color and it's closer to like 0.75. So what you're trying to do here is you're trying to get this color green pretty much exact so that you can tell which pixels are that green color. All right. So there's some cool built-in functions into GLSL that let us do operations. So I'm going to say float distance, and this distance, or let's call it diff. This is going to be, well, let's take tech color 2. Tech color 2, remember, that is the pixel color of this coordinate, right? And we're going to subtract green from it. Okay? So now let's take this and frag color, we're going to make it a vec4 and we're going to plot the difference. So let's see what that looks like. Oh, come on. Oh, so this is the vector difference between these two things. Please go away. Error. Please go away. What I want to do is once I've gotten the difference in the vectors, so let's just give you an example of this. So let's say I have one vector, which is 0, 0.7501. That is my green. That's the green that I said, right? And let's say I have a texture, which is equal to, I don't know, 1, 0.2, 0.5, and 1. Then the difference is going to be equal to 1, 0.55, 0.51. Now, I want to turn this difference into a single number, so let's take the length of that vector. Okay? So let's go back, and we can convert this to the length of that difference. So this is sort of basically the difference between the current pixel and green. So look at this. So now we've got the difference between the current pixel of the video and green, and the darker it is, the further it is away from green, right? So if I go in and change this to like, I don't know, maybe this is a 12 and maybe this is a 30 or something like that. Oops. This is like 0.05. I'm just dialing in the green color a bit better. Okay, now we've got it a bit darker, right? So now we can see the difference and we're kind of getting out the green screen. So let's do something cool here. So we're going to go back to displaying the video, right? But so by displaying the video, I just set the fragment color equal to the video color. But now I have this difference. So let's say if difference is less than some value, right? Maybe it's 0.4 to start. Then let's say, let me move this down. So if diff is less than 0.5, let's start with 0.5, frag color.a equals 0.0. So what that's saying is, if the difference between this pixel's color and my green color is within a specific threshold, change the alpha value of that to 0. Okay. Okay, nothing's happened. Let's try this to make it a little bit more obvious. Okay, so frag equals vec4 1001. So what this is wherever the difference, oh come on, vec4. Semicolon. All right. So what I'm doing here is now I've identified the parts of the image that I thought were green. And I'm saying if the difference between the video pixel color and my green is less than some threshold, set that pixel equal to red, because that's where I want to replace it, right? Now, what if, instead of replacing it with red, I replaced it with the original texture color, which was loaded from iChannel 0. So this is going to be tech color. And look what we have now. Now, Jean-Claude Van Damme is jumping around in this Paris scene. And it's done all with shaders, all in parallel. And like, pretty cool that you can do that with shaders. Now, where you would actually want to do this in your game, I don't know. But you could replace parts of textures with other textures and do all sorts of cool stuff. So this is the part of shaders that I would call sort of like color and image manipulation, right? Where we take different manipulations and we apply certain things to them. Oh, let me play with this difference. So if I have the difference less than 1, then essentially it's saying the entire video is going to be replaced with France, right? If I have it 0.1, then that's not enough of a difference to replace the green screen. So down here, I can start playing with this value. Okay, so 0.2 replaced the green screen, but we've got a bunch of green around Jean-Claude Van Damme. That doesn't look very, very good. Let's put it up a little bit more. 0.3, you can see it's reducing. Maybe 0.6. Oh, now we're starting to cut into Van Damme. And so you've got to really dial in this number. Turned out the thing I guessed in the first place was probably the best value of 0.4. So here we're able to take texture values, we're able to manipulate them, we're doing them all in real time, and it's all in parallel. So that's like super cool power of shaders 101. Second, what if we actually wanted to like draw things with shaders? Okay, so let's go over to our drawing board over here, and let's delete what we have. Let's try and use some logic to say how we might do something like draw a circle with a shader, okay? So this is, let's do a circle. Let's look at a circle like this. Okay, I wanted that to be filled. So how might we do something like draw this with a shader? All right, well, let's have a look. First of all, we've got our resolution on the top, right? So we've got our resolution and we've got our actual pixel coordinate. So we've got that, excuse me. So we've got that XY value. For example, we could have an XY value here. We could have an XY value here, over here, over here, over here. So the way we draw with a shader is not saying, okay, draw me a circle with this radius. That doesn't work. What we have to do is write an algorithm which, whenever we pick an XY coordinate, we have to say what color do we want it to be. So essentially what we're doing with a shader here, if we want to draw a circle, is say, if this point that I'm currently drawing is outside the circle, color it white. If it's inside the circle, color it black. And then hopefully, if that happens, we'll have a circle, right? So how might we do something like that? Here's one way you can do it, and there's a bunch of different ways you can do this, but I'm going to do it like this. Let's create a midpoint. So let's compute the midpoint of this, and then a circle is defined just as the radius, right? So this is the radius, or as a distance from the middle. So if we're working in ratio coordinate space, remember, where over here we have 1, down here we have 1 in, so this would be, oh, excuse me, 1 second. So this would be 1, 0. This would be 1, 1. This would be 0, 1. And this would be 0, 0. All right, so if we have this coordinate space where our x's and y's are measured between 0 and 1, where is our midpoint? See if anyone's actually awake out there. What would the coordinate of our center of this be? All right, cool. So someone's awake. So this would be 0. I can't. Our midpoint would be equal to 0.5, 0.5, right? And our radius here, so if this is our radius, this looks like our radius is approximately equal to what? 0.25, 0.25, right? Because it's about a quarter of the way across. So let's work with these values and let's see what we can do. Okie doke. So let's abandon Mr. Van Dam. And I'm going to just type in here, but I'm going to keep this open. There we go. All right. So now I'm not doing anything. Down here, I'm going to say frag color equals vec4 1, 1, 1, 1. So this should be a white image. Perfect. So this xy is my coordinate in this 0 to 1 coordinate space, right? What did I say before? Well, I'm going to want a mid, and I'm going to want a radius. All right, well, sorry, there's no second coordinate to a radius. It's just one radius. So now I've got vec2 mid equal to vec2 0.5, 0.5, right? Because that's the coordinate of the middle, and that's just a vec2. Next, I'm going to have a float radius, and that's going to be equal to 0.25. So here's my current pixel that I'm working with. Here's my midpoint. So what I can do is I can say float dist equals, and I have this length, right? And I can take the length of my current location minus the midpoint. And so, for example, if I'm currently right here, I'm going to take this, subtract the midpoint, and take the length of that vector, and that's going to be my distance. So now I've got my distance, and I'm going to say if distance, well, first of all, let's have a look at the distance. So that's my distance. That's going to be between 0 and 1, because I could only possibly be 0 or 1 away. So let's actually plot the distance here. So this is going to be dist, dist, dist 1. Look at that. So what I've done is I've plotted the distance from the midpoint to the outside here. And the highest possible value that could be is 0.5, right? Anything could only be 0.5 away. Now it turns out that because this particular canvas is rectangular in shape, that this is going to look a bit like an oval, right? But pretend we had a square here, for example. Okay, so, but if we had 2 times the distance, then our maximum value would be 1 instead of 0.5. So now we should go from black to white. 2.0, 2.0, 2.0. There we go. So now we're going from black with a distance of 0 from the midpoint to white out here. So if we think about this now, well, if dist is less than radius, then frag color is going to be equal to vec4. What did we want that to be? 0. So this means if the point is less than a quarter of the screen away from the midpoint, color it black, else frag color is equal to white. Oh, this has got to be a 1. That's the alpha channel, and we'll delete this down here. So hopefully, syntax error. Oh, didn't have a semicolon there. Compile it and run it. Look, we've got our circle. Okay? So here we have a circle, but in stretched space, right? If this was a if this was a square coordinate system, then that would be a circle rather than an ellipse, right? But because we're in a rectangle here, that's what that is. Now, you could easily make this a circle by dealing with the actual coordinates. So let's see if we can do that. So let's, instead of doing this in the ratio coordinate space, let's do it in the actual coordinate space. So the actual coordinate space, this would be x, this would be like x0, this would be xy, this would be 0y, and this would be 0, 0. Okay? So we don't have to deal with those ratio spaces, but sometimes the ratio spaces make things nicer for us. So here we have, this is the ratio space xy. So I'm going to turn this into ratio xy. And instead of typing out frag coord every time, I'm going to have just xy be the frag coord. All right. So let me see. Does this still work? Yes. Okay, perfect. Yeah, perfect. So now I have xy, which is not in the ratio space anymore. So our midpoint, instead of being vec2 0.5, 0.5, now we're dealing with pixels. So someone in the chat out there said, yes. So it's xy dot x divided by 2.0, or divided by 2. That's going to be our midpoint. And xy dot y divided by 2, because this is actual pixel space now, right? Actually, let's do pxy for pixel space. So this is pxy dot x divided by 2 and pxy dot y divided by 2. Now our radius, we're going to want that in actual pixels, right? So let's just say we want a 50 pixel radius. Now we have distance is going to be pxy minus mid, right? And let's see what happens here. Oh, geez. Oh, I got to have 2.0, 2.0. Cannot convert. Oh, this is going to be 0.0. It's very, GLSL is very, very concerned with types. Okay, so what the hell happened here? Oh, I know what happened. Yeah, so the midpoint has to be the resolution x, not the current pixel x, right? So this is the I resolutions x value divided by 2, and the I resolutions y value divided by 2. There we go. So now we have our pixel, or our circle, an actual circle of radius 50. If I change this to 150, it gets 3 times as big. And if I change this back to 50 and say now I want my midpoint of the circle to be at 100 in the x direction, or let's just say 400 in the x direction and 150 in the y direction, then we can change our midpoint for the circle, right? Because it's 0, 150. If I want it to move up, I can change that to 350. If I want it to move left, I can change this to 200. All right. Now the cool thing is, just like before, if I wanted to, I could like exchange those values of the textures for the values instead of just being black. So over here, I just have some helpful hints. So if I bring back in this texture color, right? So this is the texture color for the pixel XY. Down here, instead of coloring it black when it's inside the circle, I could have the tech color when I'm inside the circle. So what this does is it colors the texture. Oops, did I do this wrong? I think I want it this way. Yeah. So over here, now let's do something where I'm going to move this. So let's say that the midpoint's X value is going to be it's going to be, let's see, how big is this thing? Is it like 600 wide? So this is going to be absolute value of the sine of I time. So I want it to oscillate, but I'm going to multiply that by 600. So the midpoint is going to go from the beginning all the way over here and then back. And what we should have is like 600.0. Like it's a hard habit to break. And so look, now we have like a spotlight effect. Let's make this a little bit bigger. So if you want to make like a flashlight in your game, this is what you could do to do that flashlight, where you would render to a texture and then you would just mask out the portion with a circle based on something, okay? So there's so many cool effects that you can do with shaders, and they're all done in parallel, and they're all done basically instantaneously. So hopefully I'm just touching the surface of shaders here, okay? So let's just look at that. If I change this to black instead of white, and I change this 350, maybe now I'm going like absolute value of the cosine of I time times 400 in that direction. Now look at this. Ah, geez, 0.0. Okay, I've got a missing bracket. Here we go. So now, like, I've actually got like a flashlight in my game working with like, what, 8 lines of shader code? Really, really cool. I think, at least. So that's something. And if you wanted to make the inside darker, so this would be tech color like divided by 4.0. If you wanted to make that darker inside, right? Because this is a flashlight, it's not the full brightness. Just so cool. And like you can spend your whole game development life just working on shaders and doing stuff that's really cool. And in fact, if I click over here and I leave this, so let's leave the page. If I go back to the home page of Shader Toy, oh my dear Lord, the things you can do with shaders. Let's browse some shaders, shall we? People doing, so it's just crazy. People are doing like search and like complete water effects within shaders. Like all this is being done with shaders, right? So we have touched such a small tip of the iceberg that is shaders. This entire thing is being computed on the GPU using shaders. This is being computed using shaders. Like you can just browse this. This is one of the most impressive things I've ever seen in all of computer science. It takes a while to run, but I want to give it a second. This is being computed using shaders. And I'm going to take this YouTube video where the person who created this goes over how this was created using shaders, and it's essentially magic to me, okay? So all of this was done using shaders, but at the same time, you can get really basic effects out of shaders as well. All right, so that is what I wanted to show in Shader Toy, but let's close these things now because it's absolutely destroying my GPU. And let's show you how you would use this in SFML. Okay, so now we're going to do a bit of just a little bit of code inspection for the project. Yeah, that entire model is defined mathematically with conic sections. So it's absolutely crazy how that was done. So those shaders that we wrote on Shader Toy, what would happen if how do we get those into our game, for example, right? So if I wanted to take like the make something red shader, what I would do is I would create this text file. This text file is like any text file of code, except you name it .frag, okay? And here is our shader that we're going to use with SFML. So I've just loaded this up here. You can use any text editor to edit these. So we've got our coordinate. This is GL text coord. That's what it happens to be called here. We get the pixel color, which takes in the input pixel and the coordinate. And then we set the fragment color equal to, well, we're going to take the pixel color for all the things that aren't red and set, excuse me, get the hiccups, and set the red value to 1. So this shader, if used in SFML, will take the thing that you're drawing and put like a red tint over it, okay? Similarly, if we wanted to make it fade in and out, we could just change the alpha value based on sine or cosine. And so this could be like the absolute value of the sine of the time variable, just like we did in Shader Toy. You just put it into this frag thing. Now, here's what this is going to look like when we run our program. Now, I've got a couple of different shaders here. This is the fade in and out shader, and I've got it blown up on the screen here. Just it's not really this big, but my OBS just maximizes it. So this is what we could have for the fading of Mega Man, for example, right? So this is that shader applied to Mega Man. Now, the cool thing about shaders is that you don't need to recompile your program to change the shader. So here, if I wanted Mega Man to like blink really fast, let's multiply the time and we'll run our project again, which doesn't need to be recompiled. And now Mega Man is blinking much faster. Okay, so we can recompute shaders on the fly and recompile them really easily. We don't even need to shut down our program, actually. We can change shaders on the fly. It's really cool. Here's another shader where Mega Man is red, right? So maybe we want Mega Man if he got some power up that makes him red, for example. Here's Mega Man. Maybe there's an earthquake, and this shader just shakes Mega Man, right? Here's another one where Mega Man is like being stretched for some reason. And these shaders, I'm going to put them on the website under the code folder. And so you can have these shaders and work with them as like boilerplate for the shaders that you're going to use for your project. So you can see really easily now, let's take this shader, for example, and turn it into blinking red shader for Mega Man, right? That should be pretty easy now that we know about shaders. So here is the red shader, and here is the R value. So let's say we have float R equals 1.0, right? And if we replace R right here, then that is the shader. So let me go back and we'll look. All right, so here's the red shader. Now, how would I change that to be blinking? Well, I would use the sign of the time, right? So I could say, where do I have that? So cosine, so let's just say this is abs of sine of time, and that I no longer need this. So let's just rerun the program, and let's see what's happening to Mega Man now. And Mega Man is now fading, right? So this might be some status effect that you have. Maybe he's poisoned or he's on fire or something like that. Okay, cool. So let's just change that back. So that's not what I give you. There we go. So how do you actually do this in SFML? Well, what I did to make this interface, so this is like a program with an interface, and I'm hitting buttons to switch between the shaders. So in order to do that, I had to load all the shaders at the start. So the very first thing I do, and I will give you this code, is I just have a vector of strings of where all the shader files are. So in my bin directory, I have a folder called shader, and then inside shader, I have all of these shader files. Okay. Then I just have a variable which lets me keep track of which shader I'm actually pointing to. Then I set up my window, I set up my texture, I load in the Mega Man texture to display to the screen, I set up texture smoothing, I create the sprite, and I set the sprite equal to the texture. And then down here, the first thing I do, and now begins the shader code, right? So I check to see if shaders are available on the system. So this will check your current graphics situation. And if shaders are not available, it'll say shaders aren't available and print out and exit that shaders aren't available. Otherwise, I'm going to load the shader, okay? So I load the shader by I set up an SF shader. So SFML has a shader object. And I say shader.load from file, and I just pass in the string. So this is just where I hold all those strings, and I have a flag here which says this is a fragment shader. If there's any error here, then it won't open. Now, what happens is I have my SFML clock, and that is going to help me keep track of the time. Then here, all this does is says whenever I press the button, go to the next shader. Okay, so this is just part of the UI. Down here, this is how I pass. So over here in my shader code, I have this variable called time. How does this variable actually get set? When does that get set? Who gives this value to the shader? Well, over here, we have a set uniform call. So we say shader.setUniform. We pass in the variable name as a string, and we give it a value here. So the timer, we get the elapsed time as seconds, and then we set the uniform of the shader time as the time in seconds, okay? So that's all that happens. Then we set the position of the sprite, and we draw the sprite with the shader. So this is the only extra thing that we have to do, is that we have a shader object, and whenever we want to draw a sprite with a shader, we just, instead of saying window.drawSprite, we add in comma shader as the second argument. So whatever shader that we currently have, we're just going to apply that to the sprite. And so if we've loaded the blinking shader, here's what we have. If we've loaded the red shader, here's what we have. If we've loaded the earthquake shader, there's what we have. And if we've loaded the breathing shader, there's what we have. Okay? So that's pretty much it. That is the tip of the snowflake that makes up the iceberg that is shaders. Okay? It is nowhere near everything. It's not even the start of shader. You saw what people can do with shaders. You could make an entire friggin' game in shaders if you wanted to. So that's where I'm going to leave it, because I think that's all you need to know for your project. And that hopefully gives you that, you know, you walk into like a barbecue and you smell that, like that's the shaders give off that smell of, oh my God, I want to eat that. I want to learn more about it. I want to do good shaders. So in your project, for the final project specification, there's a part down here that says shaders. Some entities in the game must use shaders that alter their appearance in some meaningful way. Here are the rules. I want you to give me at least 3 shaders, and they can't be the ones that I gave you. Okay? Maybe you could use like the blinking one, but they should be modified. And by modified, I don't just mean that one of them turns it red, one of them turns it green, and one of them turns it blue. That is not sufficient. Okay? You actually have to like go out there and, I mean, you can take shaders from online. You do not have to write your own shader. And in fact, let me play my very last slide, which is some examples of shaders that you can do. Now, I'm not monetarily invested in this company. Oh, geez, that's a lot. But this video here shows a bunch of different shaders that is part of some collection that was put onto YouTube. I just wanted to show you like different things that can be done in 2D games with shaders. Oh my God, this is the loudest video ever. I don't want sound for this. 1 second. How do I turn off the sound? Mute. Perfect. All right, let me play this again. Yeah, so again, I'm not telling you to go out and buy this particular shader. I'm not associated with them. It's just a cool video that shows off some of the things you can do in 2D with shaders. So it's going to go through some of them now. I'll let this play for like 2 minutes or so. So yeah, this is pretty cool. You can have like, you can do like edge detection, background stuff. You can move, you can rotate, you can tile, twisting, like animated burn effects. Like, and the cool thing is a bunch of these, you would know how to do these already, right? You can have things shatter when they die. You can have them appear or disappear in clouds of smoke, right? People write shaders for a living and sell them because they're so cool. All right. Anyway, I don't want to like run this advertisement for this company. But these are just some of the cool things that you can do with shaders that hopefully you do go out and get for your game, because there's really cool stuff you can do.